Hello, my name is Emilio Perez Arroyo, and today I will be presenting my problem situation, which is the duration of roads, but in an individual basis. First of all, here's the abstract, and the only thing that I would consider remarkable about this is just to re-explain the objective, which was to model or to predict the future state of a 1 kilometer piece of road in Veracruz, Córdoba, using a Markov chain approach. Beginning with the results in a way, for example. Basically, as I said before, we use a Markov chain model, and we obtain that in the future state, the 50 road segments of the 1 kilometer piece of road would almost always be A, or a good state, because basically just because of the probabilities, because it had almost an 80% probability that if it was on a good state, that it would be maintained on a good state. And the other probability, which was just 20%, was spread out between the B and C probabilities. And even then, they almost always had the likelihood of passing to a good state because of a good maintenance, or that the pavimenting of these roads was really good, for example. So that is some of the information that was analyzed just by the results that the efforts of preserving the road quality were really good, or that the road itself was a low transit one, for example. But in this case, now moving into why we use a Markov chain model, was it most appropriate to use a probabilistic or a deterministic model? In this case, we use a probabilistic because the other one, the deterministic, it gives you a fixed or set outcome based on specific inputs. Basically, 1 plus 1 is always going to be 2, just to put an example. So that is something that that was a limitation, while a probabilistic model could reflect several different variables like to present the uncertainty or the randomness or of probabilities themselves, right? And in this case, because for a road condition that has many variables like the weight of the cars, the weather, transit, the events, social gatherings, for example, it was better to use a probabilistic model because it could represent those uncertainties and give us a more accurate response, for example. And so why could this model be classified as a Markovian one? Basically, because a Markovian one just predicts the future state based on the current one, ignoring past or historical data, for example. And in this case, it's the same because a road might be good today, but I don't know, something happens like a crash or many cars pass through really fast and it spoils, for example, or it could be fixed without warning and it was already a good road, So it's really, it has a lot of variables, and so it should only take into account the current state and not previous ones because that can be changed in an instant. However, we had to obtain satisfy some conditions because of the Markovian system, which were the discrete states, which basically just means that it has to have a finite set of number states. And then for we categorize those into good, acceptable, and deficient with the letters A, B, and C. Then we use the transition probabilities, which represent the numerical probability of passing from one state to the other, always in letters from A to A, from A to B, and from A to C. And so that with the other two letters for letter B and for letter C. And finally, just to check once again that this model satisfies the Markov property, which is just to analyze or predict the future based just on the current state, which, as already explained before, this system does. But if we use discrete states, how did we categorize them? Basically, we just use the RRI system, which is a standard measure of drop roughness, which basically just tells us the correlation between, basically just tells us the deterioration of the road itself. And these values change from country to country and even from some states. But in Mexico, this is the table that we picked, which basically just tells us the estado físico, which is just physical state for good, acceptable, and efficient. And we just translate it first into English and then into these three letters, A, B, and C, respectively, because it was easier to code on MATLAB. And also when the outputs were given, it was easier to just see a bunch of A's instead of a big amount of goods. It was really weird. And this is basically just methodology that we use, as I explained before. This is the Markovian chain. It just basically tells us the probability to pass from state A to state B and from state A to state C, and the other way around between the three states. In order to solve this problem, we first had to create a transition matrix, which I already explained before, but we basically just did divisions between the number of times one state passed into the other in the totals to see how much of a probability it was for each individual state to transition into another one. And we basically just built a MATLAB code that showed us the 5-year prediction model, basically just using that transition matrix, raising to the fifth power to look 5 years into the future, and then multiplied by the initial state vector, which was basically the initial values from A, B, and C that we had for the 41-kilometer piece of road. And that was basically everything that the MATLAB code did, and just gave us these results that I will not go and really into the text, but what we obtained was that the distribution of most likely states after 5 years was almost always going to be or a good state, because of the probabilities, once again, because as I said in the beginning, we have an 80% probability of an A remaining an A, and the other 20% probabilities was spread out between the other letters. And even then, it was really, really likely to pass from a bad state to a good one. However, we did notice some changes from state B to C or from C to B. However, these were really limited, and they almost never happen, especially for stages that begin A. So this tells us that although there is a risk for duration, the maintaining process for this was really good. And that's basically some part of our conclusions, that it is a good road in theory, and that it is being taken care of properly. However, to completely analyze and understand these conclusions, we first have to understand some of the limitations of this Markov chains product. Basically, it's just that the model assumes that the new states are only dependent on the current states, and that this doesn't really happen in real life. Also, that the transition matrix is constant over time when it isn't. For example, it could be seasonal for weather or for events or social gatherings, among many other things. And finally, that with little data or for little years, this maybe could not be exact, but I think for 5 years it's a good indicator, at least, if not completely accurate, at least a good indicator. And finally, that it doesn't really take into account external variables like weather, human activity, weight of the cars, many other things. And this is just the same things I already said, that A was going to be almost have the most amount of probability to remain or to be changed into a good state. However, something that it's kind of weird is that Mexico is not really characterized for having the best roads. However, it's telling us that we do. And one thing that we found out is that the Mexican values for the RRI are actually lower than the rest of the world. So it is somewhat deceiving to say that our highways are in a good state when they have, when in reality they have lesser values than in other countries. Basically, if we passed this highway into, I don't know, Monaco or something like that, it would probably be deficient, for example. So it's somewhat deceiving, but that's the reality. So maybe RI values need to be reestablished or checked upon. And that's basically everything. Thank you.